Hey guys, I hope you're all doing really well. This is the second of the 4 motherboards that I bought from eBay. You might remember last week, the first board had a blown chipset. So I'm 0 for 1 on these 4 boards for the moment. So I'm going to try and fix this one to see if I can bring up my win ratio. Now, those of you who are big fans of my channel might recognize that name, the Dell Vostro 153568. I think I repaired one of these already. So the good news is I should have spare parts for this if we need them. So let's take it onto the screen and see if we can work out what's wrong with it. And this is what the motherboard looks like when I scan that onto the screen. Now, all I know about this motherboard is that it is not powering on. So I think what we're going to start with this week, I'm going to put my multimeter into diode mode. I'm going to check the input section to see if there are any shorts. So let's start by looking for the DC input. Well, as you can see, we have our DC input right here. It's marked DC in. There are 6 pins on this, and it's pretty easy to work out what these are just by looking at the components that they're connected to. But I have a schematic for this from the last time I worked on this type of board. So let's pull up the schematic and find out exactly what those 6 pins do. Looking at the schematic, I see my DC input right here. So it's saying we have 8 pins. We've got these 6 pins right here. Pin 7 and 8 are the ground pins on the outside. So if we take a look at pin number 6 and pin number 5 are actually connected together, and they're connected to ground. So the 2 of these pins are connected to ground. Pin number 4 here, we can see on our schematic, goes off on its own path, and that is actually the ID pin. Pin number 3 has an X beside it, so pin number 3 is actually connected to nothing. And the most important one that we're interested in here, pins 1 and 2, as you can see, are joined together, and that is actually our DC positive input, where our 19.5 volts should be coming in. So I'm going to follow along the path that our positive DC input takes and check for shorts along the way. So starting right at the DC input jack itself. So it comes in here and then follows this track down onto this first MOSFET here. So let's mark in that path. And if we follow along on our schematic, we can see that path along here, which brings us up to PU4301. And as you can see, that first MOSFET is marked PU4301. Now, if this MOSFET is switched on, our 19.5 volts should come through from our source pins to our drain pins, and there it is labelled as AD+, and we need to look further down the schematic to find out where that goes. Further down the schematic, I located AD+. So the 19.5 volts should come onto a second MOSFET, PQ4410. So if we track that on our actual motherboard here, we can see that these are the drain pins of the first MOSFET, and this is the path it takes down to the second MOSFET, PQ4410, which corresponds to this MOSFET. So let's mark in that path. And if PQ4410 is switched on, our 19.5 volts should come through from our drain pins to our source pins, and then it goes on to PR4226, which is a large current sense resistor. As you can see here, right beside it, we have our current sense resistor right here, and this is our main power rail. So that's the full path of the input section. So what I'm going to check is, I'm going to check for a short at the DC input jack, I'm going to check for a short between the 2 MOSFETs, and I'm going to check for a short at this current sense resistor right here. So with the power off, I introduce my multimeter in diode mode. I place my red probe to ground and my black probe to pin 1 of the DC input jack, and I measure 0.185. So there's no short at the DC input jack. Next, I want to take the diode mode reading between these 2 MOSFETs. So the easiest place to do that is just at the drain pins of the first MOSFET. So still in diode mode with my red probe on ground, I place my black probe to the drain pins of PU4301 and I measure 0.185. So there's no short there either. And the last measurement I want to take in diode mode at this time is at our current sense resistor, which is where our main power rail is. So I place my black probe to the current sense resistor and I find that it measures 0.000. So it looks like we've got a shorted main power rail. Now, one thing I also thought that was unusual was the fact that we were measuring the same diode mode readings on both sides of that first MOSFET. So I decided to just check and see if there was a short across that MOSFET as well. So once again in diode mode, I placed my red probe to the drain pin of MOSFET 1 and I placed my black probe to the source pin, and when I measured there I found that it measured 0.000. So it seems like there might be a secondary short through that MOSFET as well. I decided it would be best just to remove those two MOSFETs and then reevaluate. So this is me taking out PU4301 very clumsily, as you can see. So that's the first MOSFET removed. And this is the removal of the second MOSFET, PQ4410. Off the board, I tested PU4301, and as you can see here, I found that it was shorted. Okay, so at this point we've established that MOSFET PU4301 is shorted and needs to be replaced. The second MOSFET, PQ4410, I tested off the board and it's testing fine. But I decided I would leave both of these off the board and check again here to see if we have a short on the main power rail, because it seems like we might have two separate faults. So measuring in diode mode once again, I place my red probe to ground and my black probe to the current sense resistor, and I measure 0.000. So it seems like even with that shorted MOSFET off the board, there is a second short on the main power rail. So if we have a short on our main 19 volt power rail, how do we find out which component is shorted? Well, we use voltage injection to flush out the shorted component. Let me show you how I set that up. So I introduce my DC power supply. I set it to 1 volt with a current limit initially of 100 milliamps. I connect my black wire to ground, my red wire to where we are detecting the short. In this case, that is at the current sense resistor. And I touch around the board to see if anything is heating up. If I don't feel anything heating up, I bring it up another 100 milliamps until some component on the board will eventually heat up, and whichever component heats up, that is the shorted component. So let me show you how that turned out. At lower currents, nothing was heating up on this board, so I increased it to 4 amps, and this is what showed up on my thermal camera. That one particular section of the board right there seems to be heating up. Now my camera is offset. It looks like this might be the chipset here, but I think it's actually the section above it that's heating up. And when I zoomed in on that area of the motherboard with my microscope, I was able to see that it's pretty obvious that this capacitor here seems to have failed. So I'm going to remove this and see if that takes away the short. After removing that capacitor, I just need to confirm that the short is now gone. So once again in diode mode, I place my red probe to ground and place my black probe to that current sense resistor once again, and this time I'm measuring 0.520. So that's far healthier. So it looks like we've gotten rid of the short on the main power rail. So having resolved the issue with the shorted main power rail, I just needed to put back in place our two MOSFETs. So PU4301 was shorted. I found an equivalent 30 volt P channel MOSFET, which is this SM3307. So I soldered that back onto the board. The second input MOSFET, PQ4410, actually tested okay off the board. So I just soldered that back in place. At this point, I think I've resolved all of the issues with this laptop motherboard. However, I really need to power it on to test it. I don't have the original power adapter, so I'm going to use my DC power supply to power the board. So with my DC power supply set to 19.5 volts, which is the correct input voltage for this, I connect my black wire to ground and I connect my red wire to the easiest place at the DC input where I can solder, which is this side of this SMD resistor right here. With the power supply connected, I observed that the laptop started drawing 0.009 amps, which is 9 milliamps, and this is around what we would expect it to draw when it's in standby. Now when I went looking for the power button to try and power this laptop motherboard on, I suddenly discovered that there's no power button switch on this board, and I don't have the daughter board or keyboard that contains the actual power switch. So how are we going to power this on if we don't have a power switch? Well, let's take a look at the Super I/O. Going back to our schematic, this is the pinout configuration for our MEC1404. This is the Super I/O. So there is one of these pins that accepts the signal from the power button to tell it to switch on. So what we need to do is to find that and then jumper it to ground to emulate the power button being pressed. So if you look at it here, if I zoom in, you can see pin number 127 is power underscore SW underscore in. So have a guess what that is. That's the signal that comes in from our power button. So let's see if we can find pin 127, jumper it to ground, and see if we can switch this laptop on. On the motherboard, I've located our 128 pin Super I/O MEC1404. So how do we work out which pin is number 127? Well, this little circle here indicates that this corner has pin number 1 right here. So let's mark in the numbers. So what we can see is this one here is pin number 127. It connects out across this track onto this capacitor right here. So what I'm going to do is I'm going to jumper this to ground to emulate the power button being pressed and see if it powers on. Just to note, in this section I have connected my black probe and my red probe wires together so that I'm using it as a jumper wire. And this is what happens when I jumper from pin 127 to ground. So we've got a power on light, and would you believe it, we've got it powered on. So that's my video for this week, guys. This one took a lot of work, but thankfully I am not 0 for 2. I'm now 1 out of 2. I've got 2 more motherboards left from that batch of 4 I got from eBay, and I'm hoping to get at least 2 of the 4 working. Tune in next week to see how I get on with number 3.